Hey everybody, welcome to the review of Chapter 5 for IM1. We are just going to go over a few of these sequence things. This is what's on your test, which of course is Monday for period 2 and Tuesday for period 7. So we're going to look at these sequences here and see which one's arithmetic, which one's geometric. Try to predict before I tell you the answers so that you know whether or not you're getting this. So the first one is 6, 9, 12, 15. Tell me if you think, or write on a piece of paper if you think it's arithmetic or geometric. In fact, why don't you take a minute and do all of these real quick and pause the video. And when you're done, I'll tell you the answer. Okay, go. All right, hopefully you did that. You paused the video. Here are the answers. The first one here, 6, 9, 12, 15. Well, maybe it would help for me to tell you what's arithmetic and what's geometric. Well, here we have a common difference. It's plus 3 each time. Plus 3, plus 3, plus 3. That makes it an arithmetic sequence. So this one goes over here because it has a common difference. Arithmetic sequences have a common difference. That's just a fancy word for saying they do plus the same amount every time. In this case, it's plus 3, plus 3, plus 3, plus 3. Also, it could be minus the same amount each time, but whatever it is, it's going to be consistent. That's what is the common difference. How do I find the 3? All you got to do is just take 2 of the numbers and subtract the first one from the second one. 9 minus 6 is 3. So that's where I get this plus 3 from. And you can do the same. You could do 12 minus 9 if you prefer, just to be sure. Oh, sure enough, it's plus 3. What about number 2? What do you think about this one? 6, 18, 54. Is there a common difference? No. These are being multiplied by 3 each time. Times 3, times 3, times 3. That's some ugly 3s, huh? These are some ugly 3s, but they are 3. So these are times 3. And so this would be a geometric sequence because geometric sequences have common ratios. And we call the common ratio R and the common difference D. How can I tell if it's geometric or arithmetic? Well, start by trying out arithmetic, see if there's a common difference. Subtract, so let's say this one here. It goes minus 2. Is the next one minus 2? Yep. Is the next one minus 2? Yep. So there seems to be a common difference here. And so therefore, this would be arithmetic. Here, it's plus 9, plus 9, plus 9. So once again, seems to me that it is arithmetic. Here, it's plus 15, plus 60, plus 40. Okay, so this is not arithmetic, right? Because it has to be same common difference. Is it geometric though? So it's times 4, and here is the weird one. This is times 1.5, and then it's times 4 again. So this is a problem. So this is going to be neither or neither, depending on how you say it. But this one here, this 6, 8, 54, 162. If you look at the differences here it's plus 2, plus 46, plus 108. You can see there's not a common difference here. It's not going up by the same amount each time. And so at that point, you got to say, well, maybe it's a common ratio. So how do you check that? Oops, I forgot that. Well, that would change the answer, wouldn't it? Let's fix that real quick. I forgot the 1 there. So again, there's no common difference here. It goes up by different amounts. It's not all the same number. But then at that point, you become suspicious. Well, maybe it's geometric. So you do 18 over 6, right? Second one divided by the first one. 18 over 6 is 3. And you try the next two, 54 over 18. Hey, that's 3. And maybe you are really not sure, so you do 162 over 54, and that is also 3. And so you can see that this one does have a common ratio, so the common ratio is 3. Here, on this one, the common difference was 3, and on this one here, the common difference was -2, and on this one here, the common difference was 9. Okay, I'm moving on. Take a look at it if you want. Pause the video, but I'm moving on. So here are some questions that are kind of like what you're going to see on the test. How do you fill in this table? Well, the left side, you always just count up from 1. 1, 2, 3, 4. And what is the t of n? Those are just the output values. Those are like, if n is 1, what's the first term in the sequence? Well, it's 10. If it's 2, what's the second term in the sequence? Well, that's 7. If it's 3, what's the third term in the sequence? That's 4. And if it's 4, that means what's the fourth term in the sequence? That's 1. And so you just have to fill in the table on the test like this. We have a common difference. Each time it's -3. So d equals -3. Again, spend a minute, try to answer the rest of these questions without my help. See if you can do it. If not, that's okay. Just listen up. The 0th term. Well, what do you mean 0th term? There's no such thing as 0th term. Well, what comes before the first term? Well, nothing comes before the first term. And you're right. But hypothetically, if there were a number before the 10, what would it be? Well, something -3 is 10, right? X minus 3 is 10. That means that x is 13. So the 0th term would be 13. Now come the equations. And this is where I lose a lot of you guys, but please pay attention. Pause it if you have to. Listen to it many times. Slow it down, but listen up. Recursive equation is always just, I'll give you the generic version and then I'll give you specific to our problem. The nth term is always, actually the way the book does it, they always do the next term. So they do a of n plus 1. It equals the current term plus the common difference. What does that mean? Well, in our case here, that means it's n plus 1 equals a of n minus 3. And so it's this right here is just a of n. This is a of n plus 1, right? That's the same as this right here. And this right here is the same as this right here. And then that d just became -3 because what is d? D is the common difference. And here we found that the common difference was -3, actually right here. So that's all you have to do for recursive. Recursive doesn't tell you how to find the 18th term. It just tells you how to find the next term. So you don't really know what came before. You're just finding the next term. Explicit equation. So in this case, it's always going to be a of n equals d times n plus a of 1 minus d. And so in our case here, we have a of n equals d, which we know is -3, times n, plus a of 1, which we know is 10, minus d, and that d is -3. So minus -3. Notice there's two minuses here. What happens if I have that? First of all, I'm actually supposed to bracket it. But what happens with two minuses? Two minuses become a positive. So this right here would be -3n plus, maybe I should keep the colors the same as they were. I'll try to keep the colors consistent. So you have -3 times n. That's such an ugly n. Times n plus 10 minus -3 Let me fix that 10. Minus negative 3 becomes plus 3. And so this becomes minus 3n plus 13. And this is your answer right here. Next up, we have 8, 16, 32, 64. The common difference, well, it goes up by 8, then by 16, then by 32. So there's no common difference. So maybe there's a common ratio. 16 over 8, that's 2. 32 over 16, that's 2. 64 over 32, that's 2. So we have a common ratio, and it's equal to 2. What's the 0th term? Well, if it's each time is times 2, each time is times 2, then what number times 2 is 8? Right? Some number, let's call it x, times 2 had to equal 8. Divide both sides by 2. X equals 4. So the 0th term would have to be 4. The recursive equation, any generic geometric sequence will have the next term equaling the current term times the common ratio. So in this case, we have the next term equals the current term times the common ratio, which is 2. And that's all you have to do for the recursive equation. For the explicit equation, the generic, let me make some room here. The generic form is that any nth term is equal to a of 1 times r to the power of n minus 1. So in this case here, we have our a1 is equal to 8. Let me give that its proper color, this 8 right here. Okay, so 8 times r, which we know in this case is 2. And then an exponent of n minus 1. And that's it. That's all you got to put for the explicit equation. This right here gives you the explicit equation for this particular sequence. Okay, this is also like what you have to do on the test. You have to find the next 6 terms. How do you do that? Well, what's the first term? Well, let's just plug in 1, because t of 1 should give us the first term. So that's 13 minus 2 times 1. And that equals 13 minus 2, which is 11. I'm going to make a little chart, and I'll have my n and my t of n, and I'll have my numbers, and they want all 6, so okay. By the way, please finish out the rest. Why don't you pause and do the rest real quick if you can. See if you can figure it out, and check back here. Go. All right, let's see how you did. So if you plugged in 1, we got 11. If we plug in 2, that's 13 minus 2 times 2 equals 13 minus 4, which is 9. Maybe you're already seeing the pattern. I'll do one more. What about t of 3? That would be 13 minus 2 times 3, which is 13 minus 6, which is 7. Can you see the pattern? It's going down by 2, minus 2, minus 2. So this would be 5, this would be 3, this would be 1. And that is all you have to do. These are your next 6 terms. Again, try the next one. See if you can do it without my help. Go. All right, here we go. So let's see what this is. T of 1 would be, come on. T of 1 would be 22 plus 3 times 1, which is 22 plus 3, which is 25. Let me make a chart for this one too. We have our n and our t of n. 1 is 25. T of 2, let's plug in a 2 for n. 22 plus 3 times 2 equals 22 plus 6 equals 28. 2, 28. One more maybe? T of 3 equals 22 plus 3 times 3 equals 22 plus 9 equals 31. So hopefully now you can see the pattern. It's just plus 3 each time. So this would be 34, this would be 37, and this would be 40. Okay, what if it's geometric? Well, remember that a geometric formula is a of n equals a of 1 times r to the n minus 1 power. And this belongs all to the r. So what do we have? Well, let's just fill in what we know. So they give us the recursive formula, and actually this should not be like this. My apologies. And the recursive formula basically says that the next term, let me put this here, the next term equals the current term times 3. So each step is just multiplying by 3. So if the first number is 10, what's the second number? Yeah, no, it's n. Sorry, wrong thing. N and t of n. So we want the 6 terms. So we already know the first term is 10. And we know that it's being multiplied by 3 on each step. So this is 30, 90, 270, 810, and 2430. And those would be the 6 terms. Notice that this right here, this 3 here, tells you what it's being multiplied by. Kind of like over here, this 2 told you what it's being added. This 3, let me use a different color so you can actually see the arrow. This 3 right here, actually, this 2 right here, this told you what you're adding. This told you what you're adding. It's actually, in this case, it's subtract. In the first one, I should say subtracting because it's minus 2n. So I'm subtracting 2 on each step, right? Remember here, it's subtracting 2. And from down here, I know it's plus 3 on each step because that's there. But if it's geometric, this tells me what I'm multiplying by. So on the next one, see if you can do it without my help. Try it real quick. Go. Okay, here we go. We're back. And I dropped my pen. So the first term is 2. Okay, and then we're told we're multiplying by negative 6. What's 2 times negative 6? Well, forget about the negative. What's 2 times 6? 12. Now let's think about the negative. Okay, so it's negative 12. So that's minus 12. 12 times 6 is 72. And we have to flip the minus each time, so that would be just positive 72. Then we multiply by negative 6. Again, 6 times 72 is 432. So this would be negative 432. Then you have to multiply that by 6. You can feel free to use a calculator, but that would be 2592. And finally, that times 6 would be two. Hold on. I lost my train of thought. I got it. It would be 15,552. Somebody check my math. I'm not even going to check. But pretty sure that's it. That was hard. You probably need a calculator for that. Or just learn how to do long multiplication. Do y'all know how to do that? I guess I should probably show you real quick. 6 times 2592. I don't know how they taught you, but the way I learned it is this is 12, this is 30, this is 54, this is 12, and then I add it all up, and I get 2, 5, 5, 5, 1. Hey, I was right. Okay. Moving on. So that's geometric. So you put that in, try some numbers, you see what it's being multiplied by, you get the next 6 terms. Leo wants to show Penn how much he cares for her, so he decides to demonstrate it through roses. On the first day, he gives her 1 rose. On the second day, he gives her 8 roses. On the third day, 15. This continues for many days. How much did he give on the 20th day? So this is the first day, the second day, the third day, blah, 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 blah. 20th day, what is it? What's that number? Well, the brute force way would just to be, well, 22, 29, 36, and you just do that till you get to the 20th term. But there's got to be a better way. So let's use our little handy-dandy formula. So remember that the explicit formula for this is arithmetic because there's a common difference, is a of n equals dn plus a1 minus d. So in this case, it's a of n equals, the common difference is 7, 7n plus a1, which is 1, minus d, which is minus 7. And so this would be 7n minus 6. Well, that means if we fill in 20, right, we want the 20th term, so let's fill in a 20. That would be 7 times 20 minus 6, which is 140 minus 6, which is 134. So that's the answer right there, 134 roses. That's a lot of roses. Hopefully it's worth it. Finish the table. So actually the test asks you not only to finish the table, but also give the formula. So let's see if we can do both. So the common difference here is 8, and the next one is 40, and I know that's not arithmetic, so it's got to be geometric unless it's an area. So this is times 5. Let me use a different color. This is times 5. This is times 5. So I'm assuming this is times 5, and so on and so forth. So that would make this 250, and this would be 1250, and this would be 6250. And so those are my numbers. What's the table, though? Well, remember, for geometric sequences, it's always a of n equals a of 1 times r to the n minus 1. So what is it here? We just replace the a1, which is 2. I'll make this green. 2 times r, which I'll keep red, which we know is 5. And I'll keep my brackets, to the n minus 1 power. I was trying to fix that 5. Didn't quite work. Okay. And that's it. That's the explicit formula for this geometric sequence. That's all there is to do. Now, that's it for sequences. There are some review questions on the test from previous chapters. So we haven't talked about graphing a line in like a month or two. And so I guess they figure, well, hey, we should probably ask you again because you're probably a little rusty. So remember how this works. You start with the y-intercept. The last number here is the y-intercept. You go find that. That's where it crosses the y-axis. That's this point right here, which I'm trying to make nice and thick, but I'm having a hard time. Okay. -1. I'm so sorry. -1. I made it +1. Okay, so let's just put it right here. That's on -1. Okay, and then remember that this number right here is known as the slope. And the slope equals rise over run. So if 2 equals rise over run, you know what? You could just think of it as 2 over 1. And so therefore the rise is 2 and the run is 1. So you take this point right here, the y-intercept, and we're going to do a rise of 2. So we go 1, 2. And then we're going to do a run of 1. So we go over 1. And this point right here, which actually I think I'll make red just for visibility's sake, would be right here. And then if you're very careful, you can draw the line, which goes something like this. Just imagine that we're straighter. And that's what you got to do. One more. Again, try this on your own. See if you can do it without my help. Go. All right, here we go. Start with the y-intercept. As always, This right here is minus 6, so that point is right down here. Now we have the slope, okay? So we know that the slope equals 1 over 3. And so that means the rise is 1 and the run is 3. So we go to that y-intercept point and we do a rise of 1 and we do a run of 1, 2, 3 to the right point, this point right here. I'm going to mark it red and then connect the dots very carefully. And that's what that line looks like. And that's it. So there's nothing else that's on the test. It's just the sequences. Remember, there's arithmetic sequences and geometric sequences. Both of them have an explicit formula and a recursive formula you can write. You might have to memorize that, so write it on a cheat sheet or on your notes. I also posted all these explanations about that on Wednesday on the stream. Go look at my notes on Wednesday. I explain what an explicit formula is and arithmetic, and a recursive formula for both geometric and arithmetic. So make sure you look at that. I also posted some other videos of other people explaining what those things are. Maybe you find them more helpful than me. So go ahead and go to the stream and check that out. I'll see you guys Monday, Tuesday. Good luck, everybody.